So in this tutorial, we're now going in the opposite direction. We're now going to go from the name to the formula of an ionic compound. Now what you'll need to have is, the periodic table like you did before, and again, you'll use it to figure out charges and also to be able to figure out, which name goes to what ion as well. Alright, so in this first example, you have iron 2 phosphate. Now, if you want to, like you did previously, if you want to split it right down the middle, between the first half and second half of the compound, and again, from that you can figure out if you have an ionic compound or a covalent, depending on if it's a metal or a non-metal. In this case, iron 2 is a metal, and usually, actually always, when you see Roman numeral, you can say that it's a metal. You don't even have to look on the periodic table. So iron 2, if you look on the periodic table for just plain iron, you'll see that it has an Fe symbol. Now, because of the fact that it has a 2 Roman numeral, that means it's Fe plus 2. If it was a 3 Roman numeral, you'd have Fe plus 3. So you have Fe plus 2. Now look at the second half, phosphate. Again, phosphate you won't find on the periodic table. So it is one of your polyatomic ions, so you do have to make sure that, again, that you know those, either by, memorizing them would be the best way of doing this. So in this case, you would see that phosphate is PO4 minus 3, like that. So you have the two halves to this particular compound. Now how is it that you put it together? Well, you can do this, what's called the zigzag rule, where you bring those charges down, but when you bring those charges down, make sure you get rid of the sign. So that what you'd end up with in this case would be Fe3, PO4, and then 2. Now that looks like PO4 or PO42, which wouldn't be an accurate way of showing it. So that's why we put the parentheses in, so that you can see, what it actually means is that you have 2 PO4 ions, is what it's saying. So that's how you do something like this. Alright. Next problem, very similar to what you just did. If you want, split it in half to be able to figure out if it's ionic covalent. In this case, you have titanium 4. So titanium, if you look on the periodic table, you'll notice that titanium is a plus, Ti actually. And then you'll notice that there's a Roman numeral, it's a 4. So you'd have Ti plus 4 like that. So that takes care of the first half. Second half is oxide. If you remember, any element on the periodic table that's a cation gets the IDE ending. So in this case, oxide is just basically oxygen. So you have O. And if you look at your the number of valence electrons that oxygen has, and also the charge that it forms, you can figure out that O has a -2. Again, because of the fact that oxygen has 6 electrons, you're trying to get to 8. So basically what it's doing is it's adding 2 electrons on to that particular element. So you have Ti4, O minus 2. If you do like you did before, doing the crisscross rule, in this case you have Ti2O4. Now you can leave it like that, but usually what you'll do is make it, bring it to the simplest whole number ratio. So in this case, this actually becomes TiO2, like that. Alright, silver nitrate. Silver, like I said earlier, is one of those transition metals that doesn't have a Roman numeral because of the fact that it only has one charge. And if you remember, silver has a +1 charge no matter what. You don't have to worry about Roman numerals for that. So in this case, silver, if you look on the periodic table, is an Ag. It has, like I said, a +1 charge. Nitrate, again, you won't find that on the periodic table. It's one of your polyatomic ions. So it's one of those that you have to memorize, which happens to be NO3, and it has a -1. In this case, the charges balance out. You have a +1 there, you have a -1 there. They balance out, so you don't have to do a crisscross rule at all. And this just becomes AgNO3. And that would be the formula for that particular name. Alright, for the last example, and I have no idea why I went in this order. I should have probably started off with the easier ones, the one harder, but that's That's how it is. So in this case, again, split it in half. Look on the periodic table to be able to figure out the charges for this. For sodium, that's an element, so you'd have Na, and it forms a positive charge, positive 1 charge. Iodide, again, because it's a cation, would get an IDE ending. So iodide is I, and it's -1. Again, charges balance out, so you just end up with NaI, like that. And that's just basically how you go about going from a name to formula, and that's with dealing with ionic compounds.